Components and circuits, part 1. Chapters T2, T3, and G4. That's tech, chapters 2 and 3, and general, chapter 4. How long has it been since you've been in a math class? You know how to do logarithmic calculations?
No.
Good, okay, well,
You won't have to.
we have them up here, and if you really, really want us to, we can work you through them, but we're going to tell you on some of these questions, whether it's math or not, just memorize the answer. Because, what?
That's what my brother said. Just memorize the answer.
There's tricks too. Okay, so and you can do all the calculations you need for this test with one hand and 5 fingers, especially if you grew up before cell phones and calculators. All right, this might be the scariest and most difficult part of the course, especially if you don't like math. All right, so we're going to tackle it head on. First thing in the course, make it easier to understand some of the concepts, as some of the concepts down the road are going to involve math. For testing purposes, you may need to do some memorization of formulas, and it may even be easier to memorize the answers to some of the questions that are more difficult, and we will be the first ones to tell you just memorize this one. Okay? Resistance is not futile.
Oh, yes, it is.
It is voltage divided by current. Resistance, what the heck does that mean? Volts, current, amps, ohms. Where did all these names come from? And we will explain every one of them as we go along here. So these names all came from that guy. Well, there's a bunch of them. George Ohm, who lived from 1789 to 1854. Ohm's law comes from George Ohm. Alejandro Volta. Volts. Alejandro Volta made the first voltaic pile, or battery. 1827, he died. That's how long batteries have been around. They looked a whole lot different than they do today, but it put out power. And André Marie Ampère, I don't speak French, died in 1836, and amps come from him. So voltage, Alejandro Volta invented the voltaic pile in 1799. So 223 years we went from I think it was a jar or a jar with stuff in it.
Actually, I think it was an earthen jug.
Yeah, I think it was earthen jar.
Yeah.
With stuff in it that was different galvanic numbers, so that you get a chemical reaction, generate electricity, to now we've got cars that can go, what, 20 miles, 15, 20 miles on a battery? A little further. Maybe.
A little further than that.
Yeah. Okay. So the volt is named in his honor. Volt is your 12-volt battery, 48-volt, 36, whatever the voltage is. Ohm's law, German scientist. In 1827, he published a paper describing what's now known as Ohm's law. And his original equation was not as simple as today's E equals I times R. Ohm is the unit of resistance. Yep, it's yellow. Used to quantify the opposition to current flow in direct current, alternating current, and radio frequency current circuits. And it's used for a lot of things, is the unit of measure, is the ohm. Ampere, international standard unit for measurement of electrical current. So how much is flowing, how much stuff is going. Is the amp, named in honor of a French mathematician. International Convention in 1881 is the first made the designation, and today it's the base unit in the International System of Units, or SI. And there you go. Some of these are on the test. The yellow arrows are on the test. Can everybody read that? It works a lot better on a big screen TV. So the red line is neutral. Okay, that's the center of the line. As you go up, you got deca is 10, hecto is 100, kilo is on the test. Kilo is 1,000, mega is 1,000,000 or a million, and giga. So think of it just like your memory in your computers. You got a kilobyte, you got a megabyte, you got a gigabyte. Well, we have kilohertz, gigahertz, megahertz, and gigahertz. And going down, we've got the deci, the centi is a tenth and a 100th, millis 1,000th. On the test is micro, and pico, which have nano between them. And then their symbols are to the right-hand side there in the column if you can read them. So you need to know giga, mega, kilo, micro, and pico. The Technician Manual, Chapter 2, page 2.
And this is important to your electronics future.
Yes, and it's important to you to understand what frequency you're on, because there's numbers on that dial and you're like, what are those last three ones? Are those kilohertz, megahertz, gigahertz, hertz? What are they? Okay, getting the abbreviations. Go by the symbols in the chart to abbreviate values. Examples, gigahertz is a capital G, capital H, small z. Okay,
And the key to this, by the way, hertz is always capital H, small z.
yes.
It's the metric measurement system that is iffy sometimes. If you look at this, you'll find that gigahertz and megahertz is capitalized, but kilohertz is not.
And some of the questions, I believe they have them wrong.
Yes, they do.
Small m, capital H, little z, and that's not the right answer because it's the wrong way to write it. Okay, megahertz is on your test. Kilohertz is on your test. Now, notice that this K is small here for the kilo.
They're not always consistent.
That's correct.
And that is the way it's expressed.
So kilohertz is a small k. Hertz is always capital H, small z. Hertz, capital H, small z, but it's not on the test, it's just by itself. Kilovolt is 1,000 volts, and that's kV. You'll pick those up. It's just a simple metric system. And milliamps is 1,000th of an amp. Okay, converting metrics. So 1,500,000 hertz equals 1,500 kilohertz. You just move the numbers, the decimal point, 3 digits, okay? Everything in here is 3 digits. That is a clue to eliminate some of the distractors that will move the decimal point 2 or 4, I'm not remember, but it's not 3. If it's not moving the decimal 3, that is not the answer. So 1,500 kilohertz times 1,000 is 1,500,000 hertz, or divided by 1,000 is 1,500. Okay, so 3,525 kilohertz is 3.25 megahertz. We moved the decimal 3 points. There's the math. Just moving it 3 points. 1,500 milliamps is the same as 1.5 amps. Now, as a marketing guy, do I want to tell you I have a 10 amp hour battery? Or do I want to tell you I have a 10,000 milliamp hour battery? That sounds a lot bigger, doesn't it? Baofeng comes out with a 1,800 milliamp battery. It's 1.8 amp hours. That's not nearly as impressive, is it?
Be careful of the mixing terms because they will.
Yes. Same thing. 1,500 milliamps is 1.5 amps, and there's the math. You move the decimal 3 points. And whether you go 3 points left or 3 points right is whether it's going up or down, milliamps, kilovolts, millikilo, all of that. Okay, so here we go. 1 kilovolt is 1,000 volts, or 1 times 1,000, or 1 times 10 to the third. 1 microvolt is a millionth of 1 volt, or 1 times 10 to the negative 6. So the negative 6 means you're going to move the decimal 6 points to the left. So it's 1 point, and then you put 5 zeros in front of that 1 and move the decimal all the way over to the front. So you've moved the decimal 6 points over. It's 0.000001. 500 milliwatts. It's 0.5 watts. 3,000 milliamps is how many amps? 3. Converting value is simple, move the decimal. And we just talked about that. So we got 3,525 kilohertz. We want it megahertz. 1, 2, 3. Boom. There's where the decimal goes. Now it's 3.525. 1.5 amps, and we want to convert amps to milliamps. It's 10 to the negative 3. Which direction do I move that decimal point? Left. How many points?
3.
3. So it's going to be 0.001. We went the wrong way, didn't we?
Go to the right.
Got to go to the right. 3 points. So it's going to be 1,500, or what? Because we're going to move that decimal point 3 points. We got to move it 1 to get to past the 5. We need 2 more zeros to get to 3. So it's going to be 1,500 milliamps. So negative is going that way, and positive, just no sign, is going that way. It's a $2 fine for phones ringing. Let me turn mine off. Okay, electrical fundamentals, moving electrons is how we do something. Moving electrons do something useful. Anytime energy is expended to do something, work is performed. Okay, anytime. And it doesn't matter if that work is something as wasteful as generating heat because you got too small of a wire. That's still work. It's generating heat, and that consumes power. So you want bigger wires. You want the appropriate sized wires. You can overdo it. Power is measured in watts. The amount of power that goes through a light bulb in the old days, incandescent light bulbs, a 100-watt light bulb. The bulb used 100 watts. You may have had some other issues with the wire heating up a little bit, even if it's a little bit, take a few more watts. But it's measured in watts. The amount of power consumed is often referred to as the load that is applied to a circuit. So you hear somebody saying it's got a load on it. That load is what's consuming the power. Our resistance is the symbol in our equations is a capital R. It's the opposition to movement of electrons. The unit of measurement is the ohm, and that's that little funny symbol over there. It's like an upside-down horseshoe, which is, with little legs sticking out. PowerPoint doesn't do a very good job of making that like anybody writes one. All materials resist the flow of electrons. All materials, even copper and gold, okay, and silver, they all resist the flow. But some of them don't resist it very much, and others resist it a whole bunch. Materials that allow easy flow of electrons through them, such as gold or copper, are called conductors. Okay? But that's not yellow. Materials that resist or prevent the easy flow of electrons through them are called insulators. And next slide should be, there we go. Glass is a good insulator, and that's in yellow. So they've got a list of them up there. You go, what's a good insulator? And there's a list of them, and the one that you want to say is glass. Current is represented by a capital I. Don't ask me why it's not a capital C, other than C is the constant for the speed of light. So it is the movement of electrons past a given point. So that's how much is flowing. Think of it as how much water is flowing past in the river. That's the current. The unit of measurement is the amp. Voltage is represented by a capital E. That's the pressure. Electromotive force, we call it, or the pressure behind it. All right, the unit of measurement is the volt, or capital V. Power, capital P. Rate at which energy is transferred, used, or transformed, okay? Unit of measurement is the watt. Again, for the power is watt. So the 100-watt light bulb. Voltage, current, and resistance are all related by Ohm's law. So here's a really cool thing. After you take the test, you take your smartphone out, and you can download an application that will do all these calculations for you. You enter in any two of those values, and it'll give you all the other ones. But for the test, you need to be able to do them manually. You don't need a calculator. You're welcome to use them during the test as long as we can prove to ourselves that they don't have memory or you can't use it. So you need to buy a $2 one at the $1 store. And no cell phones. Paper's all you need. Paper's all you need.
I just need to memorize the answer.
That'll work too. Voltage E equals current I times resistance R, or E equals I times R. Now, current I, because it's a math problem, you could switch things around. Current equals voltage divided by resistance. And resistance equals voltage divided by current. All those are the same out of E equals I times R. And we'll show you how to sort that out right there. That is not a math thing. This is a visual aid, okay?
It's a good one. This has never changed. It never will.
Right. So you see the 3 in the yellow over there. You're going to be expected to know those. But you don't have to remember anything except E equals I times R. Because then it pops up.
If you take away the quantity that you want to know, it automatically gives you the equation.
Right.
So if I want to know current,
Put your
it
hands.
is E divided by R. If I want to know volts, it is I times R. If I want to know resistance, it is E divided by R. It will always give you the method of math.
Divided by I.
Yeah, thank you.
Okay, so we've got E equals I times R is the top one on the right-hand side there, the yellow. E equals I times R. The next one is E divided by I equals R. Okay, so it's a little backwards on the side because we're keeping the single one, the R on the left, the one we're trying to solve for. So then where do you think the next one's going to be? That division sign is going to move over, isn't it? To there. E divided by R equals I. So what we recommend you do is you draw this circle and a circle just like it on the back of your, on your scratch paper. And in the one circle you write this, and in the other one you write P-I-E. And it's the same methodology, and that gives you the fourth element,
And
power,
if you know
or
any
watts.
two, you can find the remaining two.
And there are a number of questions that you could get on your test that this will answer them, and there's no guessing, as long as you figure out how to use this little chart thing. So take your paper and put the two circles in EIR and PIE on them. And we'll do the PIE here in a minute. Oh, there it is, the next one. Power is defined as the amount of energy that is being pushed through a conductor or device to do work. P is power, the units is watts, and it's P equals I times E. E equals P divided by I, and I equals P divided by E. So the first one is going to be what? P equals I times E. The next one is going to be what? P divided by I on the left-hand side equals what? E, which is voltage. Then. Okay, and then what's P divided by E is going to equal I, right? Does anybody need more time or more better explanation? It's in the book, but it's important you know this because you will actually use this in ham radio to figure out how big a battery you need to take with you to do operations.
You'll use this for a lot of things.
On the other hand, you don't have to use that because there's an app. So, and it works offline too. Okay, moving on. On the test, this is the part you have to remember. P equals I times E is the same as P equals E times I. Okay, it doesn't matter if the I times E or the E times I, it's still going to be the P. Remember that resistors oppose the flow of current. And time for questions. Which is equal to 28,400 kilohertz. So what the next step up from kilohertz is megahertz, right? And that moves the decimal 3 points, right? So 3 of those move 3 points, but 28,400 isn't going to be, let's see, 28.4, 20, it's not going to be 284, that's for sure. It's not going to be 2.8 because there's a 4 missing. So we throw 2 out. It's one of the other two, and it's already kilohertz, so no, it's not going to be 28.4 kilohertz. You don't even have to know the math. You just have to know three decimals. It is D is in delta. Okay, which is equal to 2,425 megahertz. And on your test questions, they don't capitalize them properly, so you can't use that to know which way is the right way to write it. They capitalize everything on the test questions.
As a, for instance, that top line should be capital M, capital H, lowercase z.
Right. So they're all, well, one of those up there is written in the wrong notation. Which one is that? Alpha. Alpha is wrong because that Z should be a small case. So throw that one out. Can we throw out anything because they didn't move it 3 decimals?
Yeah. Yes.
Which one?
Bravo and Delta.
Bravo and delta? They didn't move it at all on delta, did they? So what's the answer? Without even knowing, it is Charlie. Process of elimination, you answered that question. You didn't even have to know what they were asking you.
And that applies to a lot of the questions. The answer is inherent in the data.
Right. And there's no time limit, okay, other than we get exhausted waiting for you. And that's not going to happen. So take your time, which is equal to 1,500,000 hertz. Can we throw anything out with our little cheats?
Yes.
Which one can we throw out with our cheats? Bravo?
Oh, we're discussing the answer.
And we're trying to process it out. Sometimes you can't, but 15 gigahertz, to get 15, how many decimal points will we move it?
I would say you're gonna be
5, right? To get 15, we'd have to move it 5 decimal points. That's definitely wrong. So Charlie's out. All the others are viable. 1500 would be moving it 3 to the left.
okay, it's 1,000.
And 150 would be moving it what? 4 to the left, so delta's out. So Charlie and delta are out. Now all you have to just do is figure out whether it's kilohertz or megahertz, right? Okay, so which one's equivalent to 1,500,000 hertz?
Bravo.
Oh, we got an alpha and a bravo. We have a split decision.
Alpha. 1,000. You only moved it over 3. Yeah.
Kilo is 1,000 and mega is what?
Million.
And how many decimals is mega? How many decimals do you move?
6. Oh,
Yes, you were right. You were right.
confusing, man.
No, you were right. You had the number of decimals to move correct. Okay. So everybody understands that? I don't have to like, keep harping on the 3 decimal thing? Okay. Which is equal to 3.525 megahertz. I heard an alpha. Okay, we're going from megahertz to kilohertz. So the number's going to get bigger.
Yep. Oh, they're gonna get bigger.
Well, you're going from what? 1,000,000 to 1,000. So there's going to be more thousands in 1,000,000.
So it would be Charlie.
3 decimals. From mega to kilo is 3 decimals, and it's going to be Charlie. How many milliamps is 1.5 amps?
Charlie.
1,500. Which is equal to 1 kilovolt. Kilovolt.
Kilo. Charlie.
1,000 volts. Which is equal to 1 microvolt. Is it a millionth? Yep, it's a millionth. Micro's a millionth. Which is equal to 500 milliwatts.
Charlie.
Okay, I got a Charlie. Any other answers?
Bravo.
I got a Bravo and a Charlie, okay.
Yeah, I took it the wrong way.
So you're changing yours
Bravo.
to Bravo. Okay, 3 decimals, right? But of those 4, that's the only one that fits. Okay, which is equal to 3,000 milliamps.
Would be delta.
Delta. Okay, I can move it 3 decimals. I can get 3.0 or I can get 3 million. Is 3 million up there? Oh, it is.
Yep. Yes.
It is. Oh, they give you both of them on that one.
Yep.
Okay.
3.
Which is equal to 1 million picofarads. Don't worry about the name. It's a pico. That's all we care. We don't care if it's a picowatt, picovolt, picofarad. It's a pico.
You are moving from 10 to the minus 12 to 10 to the minus 6. How many digits are you moving?
6.
6. So 1 million moving 6 to the left would be 1. Moving 6 to the right would be a lot. Is there one up there that moves 6 to the right? No. But we got microfarads up there as well. Okay, so now we got a problem. Because microfarads aren't picofarads. So what do we think? Pico is higher or lower than a micro?
Lower.
Lower? So if we're picofarads, we got a smaller number or a bigger number?
We're going bigger.
We're going bigger?
I mean, we're going, no. We're going smaller.
If we're going 6, it should be Bravo. If we're going 6 left, right?
Yeah.
So micro's up here and pico's down here.
Where's that chart? Where's the slide?
It's about 50 slides back, but it's in your book. It's in your book. It's in your manual. If we moved left, it would be 1. If we moved right, it would be.
It's not up there.
So, are you going to go with Bravo then?
Yeah.
Yes. So just try and remember which one's where. You don't need to know how much of it is. Other than that one question.
So why is that one 6 and not?
Because we're going 2 steps.
Oh, two step, okay.
You're going 6 digits instead of 3.
Yeah. What is the abbreviation for megahertz? The correct abbreviation.
Delta.
Delta. You sure it's not Charlie? There's no Z in Alpha and Bravo, so surely not those. Yes, that capital H gives it away. What's the formula? What formula is used to calculate current in a circuit? Current. You want to calculate current. So current is I. Bravo, E divided by R. So does that work with the little circle? Okay. What formula is used to calculate voltage? Voltage is E. E equals I times R, right? What formula is used to calculate resistance? Bravo. R equals, let's see, E, I, R. R equals E divided by I, yes. See how I'm doing it? Okay, I'm an extra. Because I usually use an app. And I love that app. What is the resistance of a circuit in which 3 amps flows when connected to 90 volts? What is the resistance of a circuit in which current of 3 amps, really, that quick?
That's an easy one.
Oh, you memorized the answer. Okay, that works. That works. Okay, the little EIR will not be there, but
How'd you get that?
he memorized it.
Divide
Okay.
90 volts by 3 amps.
3 amps, amps is what? Which one of those up there is amps? I, current. Okay. I is the current, or amps. Okay, so 3 amps I, and 90 volts, which is E. So you got E and I. How do you get R? R equals E divided by I, right? So you've got 90 volts divided by 3 amps.
30 amps. Oh, 30 ohms. 30 ohms.
Okay, does that make sense?
But I'll figure it out.
No. You're not the only one.
I know amps are the same thing as.
Yeah. That's why it took me a long time to get this.
I'll get it now.
90 volts.
No, it's the amps and the I and the current and all that.
I'm just positioning. 3 amps goes here. So 90 divided by 3 equals,
I just took it away because I thought it was going to put up the division for you. There you go. It's the same one.
90 volts divided by 3 amps equals.
There we go.
Would you stop monkeying around?
I was trying to get it back.
Okay.
That will work. It hasn't changed.
Okay, so I is current, is amps.
And
And
or amps.
same thing.
Okay.
Current,
Okay. Now-
amps,
now
and we use an
connected.
I. Okay, we've got 12 volts, and the flow is 1.5 amps. We always want to ask, what do we know, and what are we trying to find? So we know volts, which is E, and we know amps, which is I, and we're trying to find R, ohms. So we know E and we know I, so what do? E divided by I equals R, right? Yep. So our answer is 12 divided by 1.5. 8?
Yes.
Got it now? Guaranteed to forget it before you get home?
Yeah, I just need to
But you'll learn-
memorize what the
yeah.
letters stand for.
Yes.
I just wrote the same circle, but I wrote the actual word versus the letter.
There you go. Whatever works.
Whatever works.
Okay, what is the resistance of a circuit that draws 4 amps from a 12-volt source? Now, what do we know, and what do we want to learn? Well, we obviously want to know what the ohms are. Ohms are R. So we've got E and I, voltage and amps. So E divided by I, 12 divided by 4. 12 divided by 4 is? 3 ohms. Everybody's getting it? Is everybody getting this? Anybody that needs more time on it? Or can we just like zip through? 3 ohms. Okay, current in a circuit with an applied voltage of 120 volts and a resistance of 80 ohms. So we got E volts and we got ohms or R. So E and R E divided by R equals I. So 120 divided by 80 is?
Delta.
Everybody getting this?
No, sorry.
No? Or just we're doing it too fast?
That's
Okay.
Go for it,
I'll get
sir.
it.
You can do it.
What is the current, okay, nobody answer. You take all the time you want and figure it out. We just want to make sure you got it. That you have plenty of time to answer. So nobody else answer until she's ready to answer. Then we'll see if we all got the same answer.
Trying to get I. Right, yeah. Well, I don't know where 100 ohm means. Oh, it's a resistor.
Yes.
So that's R.
Yes.
Okay. So, I'm trying to get I, so it's E divided by R.
Yes.
So E is, it's just memorizing things, volts, 200 divided by 100.
200 divided by 100 is 2.
I did that.
But you got the concept.
Yeah.
You said it right. So,
Okay, I'll figure it out.
yeah. I just want to make sure you got the concept right.
Well, aren't you trying to get
You're trying to get amps, which is
R?
I. No, you're trying to get I.
Already have R.
You have
Oh, that's where I got confused.
100 ohms is R,
Oh, okay.
and volts is 200, which is E. So E divided by R, so 200 divided by 100 gives you the ohm, or the amps,
Okay.
the I. Between this and the books, you'll figure it out. It'll become second nature. Okay, so yeah, so just write the words down instead of PIE and EIR. Okay, here we go. Next one. So, okay, what's the current through a 24 ohm resistor connected across 240 volts? So R is 24 and E is 240. So what are we looking for? Amps, and it is 24 divided by 240 divided by 24 would be 10. Yep. Real difficult math there, right? They made that one easy. Okay, what's the voltage across a 2 ohm resistor if a current of 0.5 amps flows through it? Is alpha 1? 2 times a half is?
Well, 0.5 is a half, so.
Right. Right. So, lots of questions, right? You're going to get at least one, probably 2 of these. They want to make sure you understand Ohm's law.
Especially when you look at it like a technician in general. Some of these questions are tech, some of these questions are general. They're always going to be something that you're going to have to compute.
Yeah. I like the general, figure out R.
Okay, what is the voltage across a 10 ohm resistor if a current of 1 amp flows through it? What do we know and what are we looking for? Well, we're looking for volts, obviously. 10 ohms and 1 amp?
Well, 1 times 10 is 10.
Are you sure?
No.
You're not sure? Okay. What's the voltage across a 10 ohm resistor if a current of 2 amps flows through it? So 2 amps, that's what? I is 2.
Amps and ohms.
Ohms is R is 10. So what do we got? 2 times 10, right?
Yep.
So our answer is D.
There you go.
That's Ohm's law.
It's what all these are. Okay, how much power is delivered by a voltage of 13.8 volts DC and a current of 10 amps? So now we got volts and amps, so we want to know how much power. Ooh, power is what? Watts, isn't it? And there's a clue there. All 4 answers are in watts. EIR, there's no P and there's no watts in there, is there? But we know I and E, right? We know E is volts and I is 10.
Sir, you're right.
You got it. There we go. So we're using PIE now. Power is I times E. Same little triangle thing. Okay? How many questions are there? You're going to get some on your test, aren't you? How much power is delivered by a voltage of 12 volts DC and a current of 2.5? So PIE. We got E and we got I. So PIE, I times E gives us P. So 12 times 2.5. So 12 times 2 is 24. Add another 6, you've got 30, right? That's how you do the math, by the way. You make that easy. 12 times 2.5. 12 times 2 is 24. And 12 times point, no, it's Marine Corps aviator math. When you're flying 350 miles an hour before we had watches and calculators, we had a slide rule. A circular slide rule. So yeah, you learn shortcuts. Okay, 30. All you need is your Marine Corps calculator. How much current is required to deliver 120 watts at a voltage of 12 volts? So we're looking at how much amperage now. We got P, we got the power of watts, and we got the voltages, we got E. So PIE. P divided by E gives us I. So 120 divided by 12 is? Real hard one there.
Charlie.
Charlie? 120 divided by 12.
20 divided by
10.
E.
10.
10.
10 times 12 is 120.
Baker.
Okay, so we're in class. It's okay to take shoot an answer out there. When you're taking the test, take the time. If you're not just like memorize them all, do the math. Take your time and do the math longhand. Or with a calculator if you want to bring a cheap calculator.
You use scratch paper?
Yes.
Scratch paper's okay, and cheap calculator's okay, but you can't use a calculator on your phone. You can't use one of those unless we can prove that there's no
Memory, anything that has the ability to hold a reference. So your phone is out, any memory calculator that has something in memory, that's out.
Oh!